I'm very pleased to see such a huge crowd on this very special day in this lecture hall. And this day is special because we have an extraordinary, a very special visitor, Dr. Alexei Ekaikin, who's with the Arctic and Antarctic Research Institute in St. Petersburg in Russia. Let me introduce the speaker shortly. So he finished BS studies in '96 at St. Petersburg State University, and he studied geography and geoecology. And then he did his PhD thesis in 2003. It was a combined study at St. Petersburg University and the University Joseph Fourier in Grenoble in France. And then he was a postdoctoral fellow supported by the Japan Society for the Promotion of Science from 2006 until 2008. He was stationed in Hokkaido in Japan. And since 2008, he's again with the Arctic Research, Arctic and Antarctic Research Institute. He has lectured at the St. Petersburg State University, and the most important part of his work is that he has been to the to Antarctica many times. He's participated in 8 expeditions to Antarctica, and he spent a total of 18 or 20 months in Antarctica. And now he's here to tell us something about his stay in Antarctica. And I should mention that his stay in Ljubljana, his visit to Ljubljana, is a part of the bilateral collaboration between Russia and Slovenia. So.
Good afternoon, everybody. Thank you for coming in such a huge number, and thank you for inviting me, actually, to give this talk here. It's a great honor for me. So if I'm a little bit nervous, then you may understand me, okay? And yeah, and personally thank Polona for inviting me. And yeah, it was her who organized this bilateral cooperation between Slovenia and Russia. Well, let's move on with our talk. So with this a bit strange title means that I'm going to tell you something about Antarctica, about deep drilling of ice, and about subglacial lakes. And well, you know, sometimes when you are giving a talk, you think about a phrase, epigraph, which describe the best, the idea of what you are going to say. So you know maybe this. Surely you know this phrase, fortune favors the brave. It's an old Latin expression, but that's not about us. We have our Russian version of this expression. I'm joking, of course, but you know that the role of good luck is very big in all this story, and I will give you several examples of this. We cannot neglect this factor in our life, you know. Maybe you could see this picture somewhere in news, so you know that's the beginning of February 2012. The deep driller penetrated to subglacial Lake Vostok, and I know it was a big discussion about this in mass media. I was still in Antarctica there, so I could not participate, and I could not see this news. But well, this is what I'm going to tell you about, the prehistory of this event, and why we are drilling at Vostok Station, and why we are exploring this Lake Vostok, and so on. And okay, I'm going to start with this. This is a map of Antarctica, and Russia has now 5 wintering stations, permanent stations in Antarctica. The first one is Mirny, Progress, and Novolazarevskaya, and Beringsgausen, and there were 2 more in Soviet times. Here it was Russkaya station, here Leningradskaya. So you simply can see the idea. So we wanted to make these stations all around the perimeter of Antarctic continents, just to have a kind of control. Maybe it's not a secret for you that the studies in Antarctica is mainly not about science, it's about politics. People just want to be there, to keep the territory somehow. And then Vostok Station, right here. close to the center of the continent. So why Vostok is located where it is located? And now the fortune again played its role. You know that in 1950s, Antarctic continent was mainly unexplored yet. And people decided, well, we have to do something with that, and they organized International Geophysical Year, IGY. One of the main goals was to study Antarctica, and people gathered somewhere. It was in New York, I think, and decided where each country will open their stations. And of course, Soviet Union wanted to open the station at the South Pole, you know, because we already kept more or less the whole Arctica. We had these drifting stations at the North Pole, and then we wanted to also to hold the southern, you know, tip of the planet. But the Russian delegate, he came too late for this meeting. He just was late, you know. It happens with us quite often. And the South Pole was already taken by Americans. So they have a Amundsen Scott station over there. And this poor Soviet guy, he called his bosses in Kremlin and asked, what should I do then? Okay, let's take South Geomagnetic Pole then. They answered him. And this is more or less where Vostok Station is. And then it was organized a traverse, you know, logistic transport caravan from Mirny to this inland of Antarctica. It started in 1956, and well, it took 2 years for them to go there, because they were more or less the first who traveled in the interior of Antarctica in such harsh conditions, and they used a technique like this, you know. Some of these machines are still alive, by the way. You may not believe me, but once I participated in a traverse using maybe exactly this one machine, I don't know. Still alive somehow. And well, so they were moving, and finally they said, okay, we can't move anymore, let's stop. just here, it will be our Vostok Station. And actually, if they moved just 5 kilometers more, they would have gone offshore the Lake Vostok, but they stopped just at the right place. 5 kilometers more, and there is no lake under the station. So it's just good luck, and people didn't know about the lakes at all at that time. Just no idea about the subglacial lakes in Antarctica. Well, what is Vostok Station? A short description of it. So it's altitude 3,500 meters, and that's why it's so cold and so low pressure, very difficult conditions for working and so on. Still the coldest place on Earth. Vostok still keeps the record, though it's not the highest station in Antarctica, by the way. And precipitation rate is very low, like in Sahara Desert, more or less. And well, there are many works which are performed there. A lot of scientific activity, like meteorology, of course, magnetosphere, ground glaciological observations, deep ice scoring, and Lake Vostok studies. 1970, very important milestone in Vostok history. The first deep drilling began. Not to reach the lake yet. You know, they still did not know about the lake at that time. So I could tell many stories about these guys. Well, but no time for this, unfortunately. But it was. I hope somebody will write this book sometime in the future. So why people drilling ice in Antarctica actually, and in Greenland and in other polar and mountain glaciers? Well, it was a long time ago that people realized that the glaciers are really very good climatic archives. Because, for example, at Vostok, even in summer, temperature is -30, so there is no melting at all, and all the precipitation are kept there and accumulated for 1,100 years. And if you dig a pit, for example, you may recover this fossil precipitation, as we can say. And if you study the properties of these layers, like chemical content and whatever, you may study what was climate or weather during the formation of this precipitation in the remote past. Okay, by a shovel you can make pits maybe 10 meters or so, not more if you want to go deeper. And more far away in time, then you need to apply some techniques like drilling, for example. Well, the principle is simple. You just have a cylinder or metal tube with knives on the bottom, and it's rotated and cut in ice, and then you get this cylinder of ice, which is called ice core, actually. And then you make a huge piles of these ice cores, which is called core storage, and it's like really a frozen climatic archive. And then you study the properties of this ice. These black olives here is actually air bubbles, and they are preserved there in the ice since the many years ago. So we just have samples of ancient atmosphere. We can study the gas content of it, for example. Then we can study the isotopic content of ice, and it gives us the temperature, and we can study impurities and chemical content and size of ice crystals and whatever. And after all, it appears that ice cores are maybe the best paleoclimatic archive comparing to all other sources of information like lake sediments and marine sediments and tree rings and whatever. So ice cores produce the the biggest quantity of data, and maybe with the better quality, actually. And this is a very short overview of what was produced from Vostok ice core. So we have a full climate history over the roughly 500,000 years from this ice core. We have 1, 2, 3, 4 full climatic cycles. So now we live in our warm period, Holocene, and it was a cold period 30,000 years ago, and previous interglacial, previous warm period, Eocene, 120,000 years ago, and so on and so on. And also very important is that for the first time from Vostok ice core, we received the record of greenhouse gases in the atmosphere of our planet. And now we know for sure that the amount of gases which we have now in atmosphere, it's unprecedented. It was not like this for millions of years before, It's not natural. And for the first time, it was shown that there is a very tight correlation between temperature and greenhouse gases in atmosphere, and so on. So there have been actually many discoveries made based on this ice core. And in 1999, French glaciologist Jean-Robert Petit published this famous paper, which was since then cited many thousand times. It's one of the most cited paper in geographical sciences, by the way. So I just want to tell you that Vostok was quite famous name even before this lake story. It was. This story is very long, and it already saw many successes in its life. And then in 1998, something happened with ice core. Its properties changed drastically. So isotopic signal disappeared, and gas content is dropped to zero, and so on and so on. So the properties of this ice was totally different. And the reason was found very quickly. So people just realized that we entered to the lake ice. So the ice which formed from the lake water, from the lake beneath our borehole. Because at Lake Vostok we have two areas, melting in the northern part and freezing in the southern part of the lake. And this is how I'm slowly switching into my main subject about Lake Vostok. And first question is like this: can meltwater exist under deeply frozen Antarctic glacier? 50,000 years ago, this question sounds a bit strange. Of course, no, because there is a -60 on the top of the glacier. So how it could be melt on the bottom? But well, answer is simple. There is a geothermal flux because our Earth is warm inside. So when you go deeper to the ground, temperature increases, and just the same is going on in glaciers. And if your glacier is thick enough, then at certain depths it will melt. Simply melt. It will reach a melting point. And one of the first guys who described this theoretically, it was Igor Zotikov. He was a very interesting person, by the way. He was a writer and painter and so on. And he was really good in telling stories, by the way. He was exceptionally good. And he published this picture in 1961, and he showed the areas of melting in under Antarctic continent. So he was like one of the first who theoretically proved that the lakes must exist below Antarctica. And it was another funny story related to him. In 1968, he was defending his thesis about all this, melting in Antarctica. And well, the professors did not believe to him. They said, no, it's not possible. And then, he was very lucky, because just 1 day or 2 days before his presentation, his defense, something happened in Antarctica. At American Bird Station, the deep drill went to the bottom of the glacier. So it happened 29th of January 1968. And the water came to the borehole, though radar sounding didn't show any water layer beneath the glacier. But water came, like, I don't know, to 40 meters to the borehole, and it was totally unexpected for them, and they even lost their drill. It was a kind of catastrophe, and so on. And they sent a telegram to this guy, Igor Zotikov, and he showed this on his defense, and it was a success. So he became a doctor of sciences or something like this. Okay, and I will tell you a few more milestones of this story of discovering Lake Vostok. Next important person to be mentioned is Andrei Kapitsa. He was in the 50s. He was a young guy, and he participated in second Antarctic expedition, and he made seismic soundings in Antarctic interior, and he received some, double reflections from the bottom, and he interpreted it as a sedimentary layer, but actually it was water layer, as we know now. But he misinterpreted it and remembered about these results like 50 years after that. And in '96 he published a paper in Nature about the discovery of Lake Vostok. So he is considered as the person who actually discovered it, more or less like this. And well, in '90s there were radar surveying performed by British people. So they used the airplane with a radar, and they obtained reflections typical for water, and also in the area of where Lake Vostok is. But also they did not realize that there is one single huge lake. They thought it's like water lenses spread all around Antarctica. And finally, in 1993, so after the development of satellite era and satellite altimetry, people constructed precise map of elevation for the whole Antarctic, and then they saw these very strange, huge, flat areas. So actually, the Antarctic surface looked like this. It's it's ripped like the seafloor, for example, very similar to that. But in some places, they could observe very flat areas, very unusual and not too typical. And they realized that in these places, the ice just floating on water. This is why it's so flat. And this year is actually the year when everybody said, yes, there are huge lakes underneath the Antarctic ice sheet. And this guy Ridley, he actually gave the name to Vostok Lake, just because there is a Vostok station over there. So simple. Well, just some pictures how this lake look like. It's one of the biggest on Earth. It's the 5th largest lake in the world if you consider the water volume. It's 6,000 cubic kilometers, very huge. The area is like 15,000 square kilometers. It's very similar to Lake Ladoga, for example, the biggest European lake, northwest of Russia, and quite deep, like 1,200 meters is the deepest, probably. Yeah. It's not the only one, by the way. There are many lakes, small lakes. They are shown by triangles here, and even subglacial rivers. At least people believe that it exists. And it's now a very popular subject to study because people realize that this hydrological system beneath Antarctica is very important for ice dynamics, for example. If you do not take it into account, then you may think that your ice sheet is much more stable than it is actually. So I mean that it is more unstable in reality. And we must take into account when we focused future disintegration of ice sheets, for example, or stuff like this. And yeah, this is how this subglacial river may look like. This is a real picture of one subglacial tunnel somewhere on the edge of Antarctica, close to Novolazaryevskaya station. And if we remove ice sheet, maybe the bedrock will look like this. This is an area of dry valleys close to McMurdo, American McMurdo station. And people believe it was a huge water flows some million years ago here. And if we remove the ice, maybe the rest of Antarctica will look more or less this way. So why Lake Vostok is most interesting for us? First of all, it's the biggest, okay? But it's not the only reason, you know. We think that it is quite old lake. It could exist for 1 million years already, and it could be separated from the rest of the planet for the million of years, and then unusual forms of life could develop there, for example. That's possible. Why not? And so it is considered as an analog of Earth analog of extraterrestrial subglacial oceans, which exist, for example, at the Europa planet. It's a satellite of Jupiter. Then it is located very well in terms of logistics, because yeah, we have station there. We have station, and we have a logistic transport every year, twice a year, along this route. So we may explore the lake easily, you know, more or less easily. And after all, we have a deep drilling project here, which was started much before the lake was discovered, but now it is also used as an access hole to the lake, right? And we have more than 200 meters of accreted lake ice, so we can study lake before entering it. So we already know a lot about it before penetration to the lake. Well, I just want to say that sometimes the drilling is not very easy as you can think. For example, there are many accidents happened during this drilling history, and it's a good time to tell you the secret of these strange names. So it's the borehole now is called 5G2, the name of deep borehole at Vostok. Why 5G2? G, it means глубокий, it means deep in Russian, okay? 5, it's the number of this borehole. It's borehole number 5, deep borehole number 5. The previous 4 were lost during accidents. So the drills were lost and you know, taken by ice, by squeezing ice and so on. And even for this 5th borehole, there is I forgot the English name for this. Well, it's already second deviation of the main borehole, you know, because, for example, in 2007, again, the drill was lost at this depth, and we started a new borehole, but not from the top, from the depth of like 3,600 meters. So there is a technique which allows you to make a new borehole, not from the top, but it's possible to make a deviation from the main borehole somehow. Well, what do we know about the lake already? What did we know before penetration? Well, not that many things, by the way. So we know the morphology of the lake, of course, the size, volume, and so on. We know that there is a melting of ice in the northern part of the lake and freezing of ice in the southern part of the lake. And what happened then? All the impurities and gases which goes to the lake in northern part, they just arrive from ice. They remain in the lake because forming ice, it's completely pure. Because slowly frozen ice, you know, it pushes away all the impurities and gases. And they accumulate in the lake. And this is why there is we suppose there is a very high concentration of gases and of oxygen in the lake. There is a hydrothermal activity. There are hot springs at Vostok beneath the lake. Somehow we can know about this. Well, there is not perfect mixing of this meltwater when it goes to the freezing area, and this is why maybe there are some ecological niches for the microbiota to be hidden from this high oxygen level because oxygen is a poison for microbes. And there is an ultra-oligotrophic environment in the lake. There is nothing to eat there, actually. And expected microorganism which can live there is oxygenophilic. So they must like oxygen. And it is not known on our planet still. It's just a fantasy of microbiologists. And hemaautotrophs, you understand what it means. So they feed themselves, but without life, using some chemical reactions and so on. Okay, and now few words about the last season at Vostok, which started, well, drilling started 2nd of January, and the end of the season was 5th of February 2012. Yeah, sorry, I just make some, reminder for myself that now I need to show you some pictures. It was an unusual season, I should tell you. Maybe the best in my, in my life. For my experience, it was the best one. And the miracles began already in the first days of the season. We observed a bird there, and I was not alone who observed it. I was not drunk at the time, so I have 5 or 6 people cannot go crazy, at the same time. So we observed a bird, and then after all, I asked actually people who study the birds. They say yes, it's possible that they may fly into the interior of Antarctica for unknown reason. Actually, they may be just like spies or something like this. They searching for new places where they can feed themselves and so on. So they fly any direction, and of course they die then. And it's a very pity story, but I took good pictures after all. But the resolution of the picture is not good enough, unfortunately. But it was a clear sign that something must happen this season, of course. This is our main borehole, 5G. This is how it looked like in midnight, because there is a polar day, of course, you understand. You understand why we need to use this drilling mast, because it's like a home for the drill. When we go pull it up, so it occupies all this place in this borehole. So we may then dismantle it and so on. An easy way to do. This is one of the working moments before the drilling, because we cannot just go there and start drilling. No, we need to study first the conditions in the borehole, because it's living. It may change its diameter and so on, because we use a drilling fluid to put to the borehole. If you do not do it, then it will be squeezed very fast, and it will close in maybe a few weeks or months. So we use a liquid with a density close to density of ice, and which cannot be freezed at the temperature of -60. So it's a mixture of kerosene and freon, actually. And so before drilling, we check the density of this fluid, and if it's too light, then we put more freon and so on. And it takes from 2 weeks to 1 month, this preparational work before drilling. This is one of the working moments. People take samples of this fluid to measure density then. Well, in the last days of December 2011, the drilling began, but first runs, they were empty. There were no ice core. For some reasons, we could not break it and pull it up. And the Professor Vasilyev, main driller, he looked quite disappointed. He looked into the drill, empty again. And this is why our New Year party was quite sad, Yeah. Even despite some nice drinks over there. So yeah, people were disappointed, but not all of them. Some people just didn't care at all. And okay, finally, 2nd of January, the first ice core. You see, it's quite long because it was drilled during several runs. And so you drill like 3 times, and finally you get it. So this is why it's so long. It was obtained during at least 3 runs, as far as I remember it. You can see that, for example, diameter here and here, it's different. So this was maybe 1 run, and this was another run, and so on. And this is the main glaciologist, chief glaciologist, Vladimir Lipenkov. He is the chief of all this project of exploring Lake Vostok and deep drilling at Vostok. Okay. Then, closer to the end of the season, it was 2 or 3 meters to the lake, as we know now, the ice core began look very strange. You maybe can see this very strange features there. You know, this like it was water going down along the ice core. So this is the top of ice core, and this is the bottom. So the water was, you know, flowing down and freezing. You can see this very characteristic feature. And here again, and this is how ice core must look like usually. It's completely, you know, it's beautiful. It's very smooth. Only small particles of these ice chips which formed during drilling, but otherwise it's completely smooth, you know. It looks wet here, but it's not water, it's kerosene, which is evaporating slowly. And last day ice core looked like this. So we felt that water is very close, very close. Then 5th of February, the last hours of our season, we had VIP visitors to Vostok Station. This is the Minister of Natural Resources of Russia, so our big boss, you know. And this is the head of Russian Hydrometeorological Service, also our big boss, but a bit low level. Okay. So they came just to check what is going on there, actually, because nobody of them was in Antarctica before. They just were wondering what's going on, actually. And then they gave some, you know, medals and to some people, and which is the most important, they gave us some nice drinks, like old cognac, for example. This was much more, you know, much better, at least for me. Well, and at that time we already knew that lake must be very close, because in the beginning of the season we calculated a graph like this, a graph of probability of penetration to the lake as a function of depth, you know. And on the 5th of February, the probability was already more than 60%. So it could happen really every hour, every minute. And so these guys, they left the station early evening on 5th of February. And we were going, you know, to close everything already and to prepare for leaving. But we just decided to make one more run, just another run. Just because we had some time during the night, you know, spare time, nothing to do, of course. Yeah, it's boring to sleep, you know. And well, and then it happened. So it's the time was 23:21 local time at Vostok, and so during drilling, the characteristic of the parameters of drilling became suddenly very, very strange. First of all, the pressure on the drill, it increased rapidly and extremely, how to say, to huge extent. You cannot get such a pressure on the drill if you just put it on the ice, for example. And during drilling, pressure on the drill, it never can be like this, you know, it's more or less close to zero. And the power on engine, it dropped because it looked like it's nothing to drill anymore, you know. And it took our drillers just 2 seconds to realize what's going on and to start pulling up the drill. They are really good, you know. No one of them had experience of penetrating to lakes. How do they know this? But it took them 2 seconds. They are good guys, actually. They're really good. Well, and 2 hours after that, 5 seconds after that, this is what was going on in the borehole. So the kerosene went up from the borehole because of the pressure of lake water, you know, from beneath. So what was going on actually? So the pressure of this liquid fluid was 2, 3, or 4 atmospheres bars less than pressure of water in the lake, and this is why at the moment of penetration, so kerosene did not go to the lake. No, instead of this, water went to the borehole and pushed this drill and so on, and pushed this liquid fluid up, and the level was so high that it even, you know, went off the borehole into our drilling shelter. We tried to pump it, and we pumped like 2 barrels, but mostly it went on the floor, like 1 cubic meter maybe, or maybe more. We don't know. It's just a very rough estimation. And it lasted like 5 minutes. This this fontaine was functioning like 5 minutes more or less. Then the fluid went down again, and then 2 hours later we pull out the drill, and it looked like this. It was all, like it was like a snowball. So it was frozen water all around. So it's a really good sign that it was washed in the lake water, totally. So it looked like this. We never, no one of us have seen this before. Actually, I should tell you. Yeah, and there was some ice particles which fall down from the drill, so people had to use a kind of protection. And then this is how the drill head looked like. So this huge piece of ice was frozen on the bottom of the drill. And immediately we took some samples, of course, for microbiology, for isotopes and so on. We packed and sent them to St. Petersburg. It's still somewhere in the ship in Antarctica. It will arrive on May, so don't ask me about lake, what we found. We didn't found yet anything, so it's still coming there, these samples. And then to dismantle the drill, it was not possible. It was not possible to do it in usual way. So people had to warm it to remove this ice, and only then we could, break the drill apart. And yeah, this is how the drill head looked like after we removed this ice piece. And to extract the last ice core, also we needed to warm this tube. And this is the last, really the last one, the last ice core of 5G2 borehole is going out from the drill. This is how it looked like closer. So you see that the top and the bottom are the ice core kept alive, but all the middle is crushed totally. And the drill said it's a typical picture when you, for example, if you drop ice core, it will be crushed in the middle. I don't know why, but somehow the mechanics works like this. So this picture also demonstrates that it was a huge, it was really heated by lake water in the moment of penetration. Well, this is the last ice cores which were put into the ice core storage, and also it's a coincidence. We had just the same amount of these, tubes for the ice cores as ice cores themselves. So it was exactly the same number. Well, one of the mysteries of this season. And by the way, after the last run, the drilling run, this logbook of drills, it also was the last page. So, and it was, mysteries like this all around this season. Yeah. It was very strange. And we have this special wall in the drill shelter when we write down the most important events, and I think that will be the last signature on this wall. So, озеро. You understand maybe, yeah? Озеро. Yeah, and the date, that's all. Okay, and maybe I have, what about time? Okay, I have a couple more slides if you allow me to do it. Okay, so this is what happened during the penetration. So the borehole went to the lake, and lake water went up. Now it's freezing. It freezed already, I think. And then next year we will go there and drill again. And then this is how we will study the lake water. We will study it in frozen state. We will not go to the lake, at least next season. But afterwards, after maybe 2 or 3 years, we want to continue this story. And here, slide showing you that it's not the only one lake which will be studied in next years. There is a project at Lake Ellsworth, for example. Next year they will be drilling to this lake, but it will be very fast drill with hot water, you know, without ice core. And it will take them just maybe 2 weeks. It's really fast, and it just consumes a lot of energy. Quite simple way to drill, by the way. But if you want to get ice core, then you should not use this this way. And also, it will be, I think, instead of water sample, they will get a kind of soup of bacteria or something like this, because it will be bouillon of these microbes. So I don't know what they want to study then. And next stage of exploring Lake Vostok, we call it second penetration. It will happen in, I don't know in how many years, but we want to put some probes into the lake to measure some properties and to take samples. And at Lake Elsworth, they will use something like this. It will be some robots flying around and collecting the samples. Well, and then I think that's all. And I just took 3 minutes more from you than expected. Thank you very much for attention.
Thank you very much. This was a very interesting talk, and I'm sure you have many questions. That is, the audience has many questions.
Very nice graphs from Vostok, but there is something I should know. What is with the time delay between some other things, as CO2, as CH4, temperature, and so on? Because on these slides you don't see anything.
Yeah.
You see only it's contemporaneous, but it's not.
Yeah,
now the delays are very interesting.
Thank you for this question. Yeah. Yes, indeed. When we look at the whole graph like this, when we have all these 400,000 years, it appears like it's all simultaneous, temperature and greenhouse gases, you know, changing. Where is this graph? This one? Right. Okay. But actually, it's not simultaneous exactly. But the problem is the dating of the ice, you know, and there is quite a big error, like 3,000 years, even now. Yeah, for such a time scale, it's not a big error, but still it exists. And the second problem is that the age of gas in the ice is not equal to the age of the ice, of the surrounding ice. Because the pores, you know, snow pores, they are closed at certain depth, like 100 meters below the surface. And the age of the ice at these depths is like 2,000 years, okay? And the age of the gas is 0. So there is a shift of age between gas and ice, and this is a second problem. But still, we believe that, okay, first temperature start rising, then greenhouse gases follow this rising, and then they cause the further rising of temperature. So it's a complicated process. First, temperature starts to increase, then greenhouse gases. And then greenhouse gases cause the further increase of temperature. The mechanism is, we believe it's something like this.
You know how are the delays?
No. How, the time lag? Oh, it's just, it's like 1,000–2,000 years. Another of 1,000–2,000 years, the delay between greenhouse gas and temperature. And maybe ocean play a role in this time lag, probably.
How did you measure sea level?
Sea level? Okay, so, well, ice sheet thickness data is, they are extracted from the ice core itself, because you may you may precisely measure the pressure of gas in the ice. And the pressure depends on altitude. So you just may obtain the altitude of ice sheet, and then you may recalculate it into the volume somehow. And yeah, and the sea level is just from marine sediments, of course. It's a very well-known curves from stack curve from marine sediments. And so it's two independent curves, but they correspond to each other. When we have increased sea level, we have less volume of ice sheet and so on. as must be expected.
How is this connected with atmospheric dust?
Well, so during warm periods, dust, the amount of dust is quite low. Like now, it's a relatively low amount of dust in atmosphere, but in ice ages, it was like 20, 30 times more impurity, more dust particles in atmosphere, because the climate were more like desert on the planet, and the area of deserts were bigger than now, and the area of land was bigger than now, yeah, because the ocean was low. And also the transportation from tropics to polar areas were stronger because of stronger meridional gradient. And this caused the increase of dust during Ice Age.
May I ask if you made some analysis on deuterium presence in the... You have samples of water, this, and maybe pH and such things.
You are talking about lake water now? No? No, as I said, no analyses were made. We don't have such, techniques at the station. So we are bringing samples now to our laboratory to St. Petersburg. I made the first test, actually. I tried this water. But it smelled too much like kerosene. So I even cannot recognize if it's salty or if it's fresh. I think it's fresh, but I'm not sure.
What is the temperature of the water, lake water? Is it close to 4?
Temperature of the water at the boundary between glacier and lake, it's melting point, of course. It's -3 degrees. It's not 0, it's -3, right? And if you go to the bottom of the lake, it might be increasing, because if there are hot springs there, then it must increase somehow. Maybe to plus 40, 60, I don't know. Yeah, we don't know exactly about this yet.
Do we have more questions?
What happens to the drilling shaft between the seasons?
Well, it's somehow conserved, and but now there are 2 people there, 2 drillers. They will not do anything in the borehole. Maybe some geophysical measurements. They will not be drilling, but they are wintering there just to keep an eye on all this stuff and so on.
So it's just preserved the world we live in.
Yes. Yeah.
All these years.
Yeah. Exactly.
There's another question about the lakes, because I was told in Greenland was at first the dust and then the temperature.
Well, Greenland, it's another story, of course, because it's much smaller than Antarctica, and Antarctica, it really affects the climate on the whole planet. And as for Greenland, it may be other mechanism, because it's smaller and it may be influenced by other parameters, climatic parameters, somewhere else on the Earth. Well, actually, I cannot answer your question properly. I don't know the good answer for this.
Up to now, this is the picture we are looking at is the most spectacular one of the whole drilling in Vostok. Do you expect that it will be possible from the water inside the lake to get so important results as these are here? These have explained a lot of things, these graphs here, as regards the paleoclimatology. Is there a chance, this is more or less guessing, is there a chance that also in the lakes there are such big stories as these curves here?
Well, I think no, actually. If we will study the lake sediments in future, then there will be also climatic curves, but it's just dreams now. But I think that the lake itself, it does not feel the changes on the surface of the glacier, because even these huge climatic waves, it cannot go as deep as to the lake. It may feel the thickness of the ice above, for example, but it does not affect the lake very much. So I think no. As for this paleoclimatic story, I think the lake will not give us new data. It's another story, of course.
Do we have more questions?
Which seismic method did you use for discovering the lake?
Which seismic method?
Yes. Was it reflection seismics, VSP, or something else?
Reflection, yeah. So they make a big, like big bang, and then they listen to the echo and measure the time delay of the echo.
There was on your sketch of drilling holes when they bifurcated. There was also some layer of what it said sediment or something. And so it seemed that the certain depth, the drilling encountered some layer with mineral inclusions. You said, yeah.
You mean this one?
Yes. What was that?
That's an interesting story. Yeah, it's in the lake. Lake ice is divided into big parts. Lake ice 1, just like this we call it. Lake ice 1, it's with mineral inclusions, and lake ice 2 without inclusions, completely pure. And we believe that lake ice 1, it's on the upper part of the lake ice thickness. It was formed close to the coast of the lake, where glacier was scratching the bedrock and so on. And lake ice 2 completely pure. It was formed over the deep part of the lake, closer to Vostok station. And there is one layer which is extremely rich in mineral inclusions. And if I don't know the picture with me, but if you look at it, you just see this layer of many particles, and some of them are quite big, like 1 centimeter in diameter, for example. Huge ones, yeah. So, and we use this layer, to adjust to ice cores, 5G1 and 5G2. This is why we started this deviation from quite above, because we have this layer of minerals in the 5G1 and 5G2, so we may adjust the depth then.
Thank you.
What kind of analysis are you planning to do with biological samples?
Well, all kind of possible things, I guess, because I'm not doing it personally, of course. We just send these samples to our colleagues from St. Petersburg Institute of Nuclear Physics. There is Sergei Bulat, the name of this microbiologist, and he uses DNA analysis somehow to describe the microbiological content. Also, we collaborate with Institute of Microbiology in Moscow. They use classical method. They observe this in microscopes, and they try to cultivate
Any
these
results
microbes.
yet?
Well, for the lake ice, they just discovered that it's completely pure. There is less than 1 cell per 1 millimeter of ice. It's just nothing, it's zero, And up to now, they could find only one microbe that we believe was existing in the lake bottom. It's a kind of hydrothermal bacteria living in hot springs. This is why it's one of the reasons why we think that there are hot springs there. Not the only reason.
We have time for one last question, if there is one.
Are you going back to Antarctica?
Yes. In November, I hope. Yeah.
Let's thank Dr. Rekaikin again.